Okay, guys, this one's going to be Chapter 5, Probability Tables, Missing Elements, Expected Values, Standard Deviation, and Random Variables. So I'm going to use this one as an example for the probability table. So you guys remember when we had these tables, right? And we had to add up all the numbers across, all the numbers at the bottom, and then the total, right? Okay, so I did that, right? That's what you're going to do if you see this and the totals aren't already there. You're going to add them all up. Okay. So it says, what is the probability that a randomly selected person smokes? Okay, so we're trying to see if someone smokes. So that's going to be the total, 512. And since we're talking about everyone, we're going to put it over the total. So this one's going to be 512 over 825, right? Okay. So now it says, what is the probability that a randomly selected person smokes given that the person did not complete high school? Okay, this one's really important. And so whenever you see given is always going to go at the bottom, right? So if it says smokes, so you're going to do, okay, they smoke given that the person did not complete high school. Okay, right here, right? They smoke and they didn't complete high school. But how do you know which one to put it over, whether to put it over this one, or this one, right? Well, if it says given is always going to be at the bottom, right? So what is given? It says given that the person did not complete high school. So it's going to be this one, right? This is your given. So it's going to be under 214. So it would be 113 divided by 214. And then you just put in the calculator and you get this answer. But like, it's really important that you remember that whenever it says given always goes in the bottom. So if I said, what is the probability that someone did not complete high school given that they never smoked? So we're going to be right here, right? So it's going to be 82. They didn't complete high school, but what do you put it over? Given that they never smoked. So it's going to be this column at the bottom. So it would be 82 over 357. So remember, given is always at the bottom. Okay, so we're going to kind of do the same thing here. So this was one of the FRQ practices that we did, right? Okay, so it gives you the table. This one already gave you all the totals, so you don't have to worry about doing that. So let's look at the first one. It says, what is the probability that a person chosen at random from those in the sample will be in the 31 to 45 age category? Right, okay, so this one, notice how there's no given, right? So if there's no given, you're going to most likely put it over the total, right? So it says they want everyone in the 31 to 45 age category, and everyone chosen at random from the sample. So that means that it's like the total. So 31 to 45, we go over here, it's going to be 89, right? And then it's going to be over 207. So over here, I said the probability that a person chosen at random will be in the 31 to 45 age range is 89 over 207. You can just leave it as a fraction. You don't really have to calculate it. But let's look at the next one. It says, what is the probability that a person chosen at random from those in the sample whose incomes are over 50,000 will be in the 31 to 45 age category? Okay, so this one's a little harder. This one you kind of have to like think about it a little bit. So it doesn't say the word given, and sometimes they won't tell you given because they don't want to make it that easy for you, right? But so this one is going to be given, right? But how do I know this? I'm going to know this because it says, what is the probability that a person chosen at random from those in a sample whose incomes are over 50,000? So we already know that they're going to be over 50,000, right? So that's going to be your given because they told you they're going to be over 50,000, right? So you have to like make a mental note that that's given. And you're trying to find out the 31 to 45 age category, right? So we're going to look at the 31 to 45 age category, and it says over 50,000. Okay, so we're going to go over here. We're going to go over 50,000. So that's going to be 35, right? But remember, since we said that they gave us given, which is incomes over 50,000, we're gonna put this number under or over this number. Remember, given always goes in the bottom. Remember? Okay, so then for B, I said the probability that a person chosen at random from those who have an income over $50,000 and between 31 to 45 is 3.6%. And then in parentheses, you have to show your work. So I did 35 over 96, and I showed my work there. Okay, so that's how you do those ones. Okay, so this one's going to be a little harder to remember. Okay, we're going to do C. Based on your answers to parts A and B, is annual income independent of age category for those in this example? Explain. Okay, so what does this mean? This one means if they're independent, it's knowing whether or not one event, why did it blur? Knowing whether or not one event occurs doesn't change the probability of the other event. So, basically, how you're gonna solve this is, for this one, it's like easier for you because you already did the work, right? So what you're gonna want to do is you're gonna want to do the probability of 31 to 45 age. This little line means given that they earn 50,000. That's what we did in this one, right? So, and then you're gonna compare it to this one, the probability of just being 31 to 45, right? Which is what you did here. So you kind of want to see if like they're like independent or they're dependent on each other. So you got your answer here, right? So I just put that underneath here. And then this one, you already got your answer here. I just changed it to a decimal point. It was 0.429. So if they aren't equal, they are not independent. If they are equal, they're independent.